As Jim introduced me earlier today during the keynotes, I am Andy Akenson. I'm a software architect here at Autodesk on the Inventor team. Just a little bit about me. I've been at Autodesk now for 12 years. All of those 12 years have been on the Inventor team. Super excited about that. I think it's a great product. I'll go into a few more details on Inventor here in a minute. But really the last couple of years I've been focused on getting Inventor technology into Forge and in part of our design automation service. So that's really what this really long title here, this automation workflows with Forge Design Automation API for Inventor, is really all about headless version of Inventor running in Forge so that you can automate and collaborate at scale. So that's really what we're going to dive into here in detail. Probably haven't seen this one enough. It's our safe harbor. I may talk about future things. I often do as part of what I do as software architect. Don't take it as a guarantee, but if you have questions, come see me after the session. I'm happy to chat with you and tell you where that falls or doesn't on the roadmap. So before I get started, these are the main talking points. So I always like to say, so I'm a software architect. I'm going to dive into some of the technology. One of the things that I really do here at Autodesk is help bridge the business and the technology. But if these things in this agenda isn't for you, feel free to get up and leave. I'd much rather have you go find another class than be bored here and we're really the heart of this is going to be walking through what design automation is, what it can do for you, and really the meat of this is a demo showing what you can do with it. So I'd like to start this session with a little story about my daughter. So she's currently 18, but probably when she was about 2, and even today, one of her favorite questions is, what does it do? What can I do with it? What value is it to me? So that's always been something that I've had to answer for her. And so it's something I really want to dive into here. If you're looking for how do I get started with this, we'll get a little bit of the how, but this is really a what session, right? So we're going to talk about Forge, design automation, walk through a customer example, and then really walk through a demo of what you can do. Nobody took me up on my offer. That's great. You all stayed. So let's start this with a few numbers. If you look at the number 20, by itself, it's not a very big number. But in software years, it's huge. So just this year, Inventor celebrated its 20th anniversary. So I've been working on Inventor 12 years. There are times I'm in meetings with people, I'm still the rookie in the room. It's amazing how much our customers have done and how much the team has been committed to delivering that to our customers through the year. So just to put it in perspective, we're talking about Forge, we're at a conference about new cloud technologies, and Inventor is still relevant, it's still fresh even after 20 years. So this is pretty interesting. I did my homework here on this, and our API for Inventor was first released in R4. So that was almost 19 years ago. The API has been available. The Sketch API, I think, was the first thing that came out. You can still write that same API today, and you can still bring that into Forge. So I thought that was pretty cool. As Jim mentioned before, design automation for Inventor, Revit, Max, and AutoCAD was announced last year at DevCon. So we've actually been out in beta now about a year. We've been getting a lot of customer feedback. And as part of that, we have run over 1 million jobs so far in beta just on Inventor. So just to let you know, we have been in beta, but we've really had people push it, either from number of jobs, size of models, workflows they're looking at doing. So I'll share a little more about that here today. All right, so it all starts with Forge. So some of this was kind of skimmed over in the keynote. I want to really talk about what this means for people in the mechanical, specifically in Inventor world, automating their workflows, right? So Forge really is this set of web service APIs built on industry standard technology, right? So as we've talked about, the Inventor API has been there forever. This technology changes all the time, right? But it's easy to get web stacks up and running. It's easy to deploy them. Really, Forge is built on that. And so I want to go over what's kind of at the Forge API and then where Inventor comes in here. So again, as was mentioned, Forge really does enable your digital transformation. And the thing we're really going to focus in on here today is, we'll talk a little bit about the visualize part. Definitely there's a place to organize your data, connect and collaborate, whether it's inside your company, with suppliers, with your own customers. But really what we're going to talk about is automation. An automation that starts in Inventor, continues through Forge, and then usually ends up either in the shop floor or maybe back in an ERP system. So those are some of the things we're going to talk about here today. And I think this was covered in the keynote as well, but really wanted to highlight here, two of the primary workflows that we are talking to our customers about within Forge, not just design automation, really are around configuration and automation. Right? I think there's a pretty big demand for that, although it's not the only thing we're looking at in design automation. Right? We really do see some of these benefits from being really freeing up from the desktop in terms of like collaboration and insight and time to market, but as well as being able to automate things, so you really do have less errors, costs, and waste. And we've really seen that as we've had customers push workflows through design automation. Right? So this was covered a little bit too. These are all the building blocks out on Forge today. So if you look here, we have everything from authenticate to, we have a token flex API to see what your consumption is. My examples will heavily leverage the viewer, design automation, Forge data management, but there's also the model derivative service that a lot of customers also experience when they're hooking up workflows based on design automation. Right, so this is all out on forge.autodesk.com today. You go out and take a look at it. And with that, I want to expand a little bit on the story that Jim told today around the Advanced Drainage Systems Configurator. And really, I want to start at the very beginning, and we'll walk that all the way through to what that meant to them to bring that on to Forge. Right? So we've got this big drainage field configurator that Imagine it worked with ADS on. Jim mentioned it's basically a bunch of series of tanks and pipes that are highly configurable, but you need the documentation to actually go all the way back out to site. So what does that really look like here? And what did that really do for both ADS as well as Imagine it, helping them get there? Right? So I think this top quote really summarizes it a lot. And they've been pushing this in beta. They kind of pushed some of the edges on size of model and some of the things we can do to end up with actually a pretty good experience at the other side. So we really did help decrease their time, really enabled their customers, their dealers, their civil engineers to self-serve the site designs, right? So we took technology that was stuck on the desktop and we put it in the cloud, and that really made it accessible and available to anyone, anywhere. So I want to walk through this demo from the beginning, all the way back in Inventor. So as with most things I'll talk about today, the designs start in Inventor. They don't always have to. I've talked to some of you actually here today even about even taking other CAD formats in, and I'll talk a little bit about some of those workflows as well, but really want to focus on Inventor. And often in Inventor you have these highly engineered models. And often that involves, whether it's your parameters or often iLogic rules. And so for Imagine it and ADS, that really meant they had this big iLogic form that really drove their model to be able to provide the 2D output on the other side. So we'll go ahead and start this. Right, so starting in Inventor, we can see here that they have a base 3D model that can basically drive any configuration to be able to configure the number of pipes, the number of inlets, the size of the tank. You can see here, it does start in Inventor. You can see they have a whole bunch of rules, not just a couple rules, but they have tons of rules that drive these pipe configurations, right? And then what was done on the desktop before, then they're able to, I'm just going to show here, yes, they do actually have a whole bunch of rules in place, right? So we're able to take those exact same rules, that exact same base model that was a desktop-based solution before, and they're actually able to then bring this was actually their exact same desktop UI that was a web-based local UI. They're then able to bring that into Forge. Like Jim was showing, they'll actually set the scale based off of the scale on the underlay. So they'll take the site plan, actually bring that in as an underlay, set the scale. They're then going to actually rotate that underlay to align directly with the model. And the great thing is here, this is a parking lot, right? So they actually have that space that the impervious parking lot's going to cover. And then based on that parking lot size and the size of the model, they also have a bunch of settings that they'll put for whether it's flow. They have a bunch of other inputs for those iLogic rules that are now surfaced on a web page in Forge. Right? They're going to set up that area, and all of this is going to feed into Inventor on the back end. Right? So once they're happy with that, like Jim mentioned before, they go ahead and save that off. And out the other side, eventually, is going to come a 2D drawing, right? So they'll get, maybe, it's coming. Oh, there we go. Yeah, so they get both a PDF as well as the twig file that they can bring into AutoCAD. Right? And what's important here is they started with that same exact model in iLogic code on the desktop. They're able to bring that into Forge, use Forge's collaboration, and then end up with 2D out the other side that they can actually be used in the field, all with that existing power of Inventor. Right? So this was actually a really good exercise for the team to make sure that we could follow through this whole workflow on a fairly complicated model that had a ton of iLogic. Right? So I want to take a step back now and really talk about what is design automation. Is it for you? What are the basic building blocks, and where do we go from there? So, as was announced today, design automation, what we call V3, V2, AutoCAD was already running. It will be available at the end of the month. The pricing is already up on forge.autodesk.com, so what was mentioned this morning is actually now out in the public. Just checked that out earlier. And it's really providing the power of these core Autodesk products in the cloud so that you can automate and collaborate at scale. Right? So we look at Revit, we look at Inventor, we look at Max, and we look at AutoCAD. And it really is part of the engine that drives AutoCAD Web and Mobile. So AutoCAD Web and Mobile traffic already goes through design automation. We share the same front-end infrastructure for all of these engines. So you can know this was actually done not as like a pet project or a proof of concept, but we're actually driving a lot of revenue generation through this today. All right, so it's been proven out. So if we look at just general flow for design automation, what happens? What does it do? At the core, it does exactly this. So you have your input design files and you have some code. That code can be iLogic in an existing design or it can be an add-in. You bring that to design automation. We process that on our servers in the cloud. And we give you the outputs. And those outputs typically then are new design files, or derivative types, like some of the PDFs we showed you, as well as some reports so that you can see what actually went on during the processing, to both help in debugging as well as mining some extra data for what went on during your actual run. So if we look at the actual workflow then, what does it take to actually run one of these jobs of design automation? So we start down here at the bottom with you. Typically that would be a web service that you have running. And you have to make your data available. So we need your input files to be able to actually process it. So what I'll show you today is an example using Forge data management APIs. But really it could be anything. It could be Azure, it could be Dropbox, it could be really anything where we have access to it. So you will give us either authentication headers or assigned URL to be able to then, you tell us where your input files are, you give us access. It could even be just for a short amount of time. We download those links onto our worker. So this is our worker over here. You've already told us, you've already uploaded your code. So we're going to run your code. So let's say it's an Inventor add-in. We'll walk through what that actually looks like here in a minute. We then will put those results wherever you tell us. Again, it needs to be in the cloud somewhere. We need to have access to put those results. And we don't hang on to anything. So once we're done with the job, we wipe that worker clean. And we'll walk through that in a little more detail here too. So I want to walk through a high-level workflow here to just show some of the power, not just of design automation for Inventor, but you could actually chain this together with design automation for Revit, design automation for Max, or AutoCAD, right? So let's say you start with a highly engineered pump system in Inventor, right? So this is a full assembly manufacturing detail level here. We're going to send that to design automation for Inventor. And we're going to shrink wrap that thing. Maybe we're going to shrink wrap it, we're going to define some connectors and pull out some metadata that then we can hand over to design automation for Revit. And using an add-in over there, we can actually pull in some of the facilities management information then for that model that we just brought in. So we went all the way from a highly detailed mechanical design all the way over to something that can be managed in facilities and then sent to your building. And then you can even think about, well, okay, that's great. I now have it in my Revit model. You can even then send it off to Max because maybe you actually want to do a walkthrough or some animated instructions on maybe it's a facilities management person who needs to do a walkthrough. So you could glue multiple engines together depending on the workflow. So if you take a step back to one of those first slides I showed with the Lego bricks, right? We're really providing you some of the core building blocks to build out automation and collaboration solutions in the cloud at scale. So when we think about that for Inventor design automation, typically that falls into one of these three buckets, right? And I've talked to a number of you here today already, a lot about the configuration step, right? So there's a lot of interest in sales configuration tools. Maybe you have a customer website that you want to have your customers enter, the rules or parameter changes that will be run on the back end. You want to integrate with maybe an ERP or CRM system to pull pricing and material data out, or you want to generate manufacturing documentation that's going to end up on the shop floor, right? So we've been talking to customers who do everything from that initial sales quote all the way down to something that's going to drive the shop floor. Right? So that's been actually really fun. The heart of a lot of this has been iLogic and customer add-in code. But you can leverage your existing iLogic investment. We also talked to a lot of customers about export. So you can think of this as basically custom save as, where if you have a little bit of code, so let's say you want to put a watermark on PDF, you can do that with your code, right? Or you want to change the settings for an STL output because you have a highly specified 3D printer, right? You can do that in code in the cloud without actually needing that version of Inventor just to export it out to another file. We've talked about generating a lot of drawings. So at the end of the day, lots of drawings get generated, the BOM gets extracted, and then custom interop with back-end systems. Maybe we're just a node typically in existing customer workflow pipelines. And then we look at generate. We have customers generating parts. They'll get custom orders that come in, they'll generate tens or hundreds of thousands of parts. They don't have to have those on the shelf, they can just generate it from rules. Model validation, definitely talk to customers about validating in the cloud. So let's say you get to a certain checkpoint, you want to be able to run that through a model validator. You can do that as well. And then other bulk operations, maybe things that you've used Task Scheduler for in the past, maybe it's a bulk migration you want to do. You can now do that as well. Again, without needing that seat of Inventor, or without needing to tie up your machine to do it. So we already developed our conference. So how do you actually write code? Okay, I'm talking to you then. No, if you look at the API for design automation, even if you're not into code, these are the basic concepts that we deal with, right? So we talk about these four basic concepts of work items, activities, app bundles, and engines. The whole API really does boil down to those four primary interfaces that you're going to deal with. So when we talk about these, at a general concept, if you take it from a programming standpoint, you can think of work items as the actual function call, the thing that does the work. Activities are the interface into that function, or what gets passed in and what comes out. Right? App bundles are like a shared library, or the actual code that gets compiled. And then engines are the instruction set. So they're actually what gets run on the processor. So if we take that to a product concept, right? Work items really are the job. So if it hasn't become obvious yet, design automation is a job-based system. So you define the job, we run the job for you, we give you the outputs, right? That work item is the thing that runs. The activity defines the interfaces. So if it's an Inventor assembly, it's going to define a zip file that comes in. If it's a Forge viewable, it'll define a Forge viewable that comes out the other side. The app bundle is your actual plugin. So if you've written an Inventor add-in today, that's what it would be as your app bundle. We have a little bit of packaging around that, but it's basically your add-in that you've written, or potentially somebody else has shared that you can just run. And then the engine is Inventor. And I'll go into a little more detail about how we actually run that Inventor in the cloud and what impact that could actually have for you as you look to get your design automation API hooked up. So the Inventor engines today, currently in beta, we support 3 versions. We support 2020, 2019, and 2018. Typically with Inventor, we support the current 3 back. So I think as we start adding versions, we'll just support whatever Inventor supports. Now the important thing there is, whatever you tell us, that's the version you get out the other side. So you don't have to worry about migration and file compatibility as long as you can run the versions that we support on the cloud. We really do. We're set up to run in parallel. We auto-scale these workers up for you. So if you have an on-prem automation solution today, I've talked to a lot of customers where this is really impactful for them, right? We can spin up 100 workers. If you've got 100 jobs, now we have a scheduling system to make sure it's fair, but we really do ramp these things up as demand comes in. We really are optimized for Inventor workflow, so we've used a lot of our data as it's come in. So these 1 million plus jobs, we've been able to make sure we have right-sized instances to process those jobs. We already load the iLogic translator and plugins, so all of those workflows I described earlier, if you need a plugin today, they should be there and ready to go, as well as your own plugins and dependencies that you can upload. I mean, you don't need a license. So as was mentioned earlier, it's 6 cloud credits per hour to run. If you're doing this on-prem, it would be a lot more than that just to run a token for that. One job may cost you a whole day's worth of token to run. So there are a few limitations because we are running in the cloud. We don't have a full version of Excel on the workers, but we are able to read your Excel files. So basically what this means is if you have something like a linked parameter in Inventor, we can read that, we can use that. We can consume that, we just can't write it back. So if you have VBA code that writes back into Excel, we're going to have to rethink that. A lot of customers, if they need that, will generate a CSV and then have to have another tool that brings that in. Back in. So definitely talk to other customers around that. If some of these limitations and restrictions you think are going to get in your way, come talk to me afterwards. I'd love to chat with you about that. So we don't have sticky sessions, which means we do exactly what I mentioned before. We process your job, we don't hold on to your data, we give it back. Definitely talk to customers who would love to have either more persistent sessions or better ways to glue together parallel processing. If you think that's one of your needs, again, come talk to me. Not only am I software architect on the team, I'm actually the product owner as well. So I directly influence the backlog. I really want to hear what your actual demands are here. And if some of these things don't work for you, let me know. And then you don't have, so Inventor Server is no UI. So some of our add-ins use the UI layer of the API that puts things like tube and pipe, cable and harness, frame generator. Now we can consume the outputs of those. We just don't have a way to generate a pipe run today. So we're looking at ways to refactor that, but as it stands right now, that there are a few limitations in that area. We also do run in a sandbox. Because we're running in the cloud, we're not just running our code, we're running your code. And that can actually be kind of a scary thing because we don't actually know what you're going to upload. So we actually do a bunch of process isolation. We limit the directories you can get access to. You can talk back to your web server. You're not going to be able to talk to anything else outside of that. So again, if that's going to be an issue, come talk to me. That's where we currently are with our sandboxer. It's been working pretty well for our customers who are currently in beta. Right? And then we do have a number of quotas and limits in place. I have been able to tune some of those for some customers. So again, that'd be another great topic to come and talk to me about. So I want to just take a quick walk through what the actual API documentation looks like. So Has anybody here gone through the Design Automation API out on Forge? Let me give you a little tour. So you start at forge.autodesk.com, you go to documentation, here are our basic building blocks, right? Go to Design Automation, go to Developer's Guide, this will walk you through AutoCAD, Max, Inventor, Revit. There are things specific to each engine, they're all documented here in the overview. Right, we have some API basics, which will go over the general terminology. A lot of it I just covered here, but a lot of that's in more detail here. There's a field guide, so how to actually work with some of this stuff, what the relationships are between some of these main building blocks, as well as some examples on some things that are product specific. And then here's where our rates and limits are actually documented on Forge. So they're documented per engine. You know, these things are enforced at runtime. I do have a way to override some of these things. So if these won't work for you, let me know. And then we have a bunch of other things here documented. You know, how to work with aliases and IDs, how to work with callbacks. You know, there's various things as you dive into the API, as well as a step-by-step tutorial for each of the engine types. So this provides language neutral, basically REST statements that are going to be made to actually walk you through the basics of design automation, right? So each engine type has a specific workflow that they'll walk you through a simple setup and run of a work item. And then we have specific API references as well. So if I want to go find out what are my list of activities right now up on Forge, here's the endpoint. Here's all the headers, input parameters I've got to set up, the response codes, as well as examples, and you can just plug this in and run it. Right, so we put a lot of effort into our Forge documentation. Actually, as we've been getting feedback from customers, we've been working on improving it. There are places to go for help, like Stack Overflow, as well as our health dashboard. So you can actually see here, real time, if you think we're having an issue with Forge, go check. Forge is currently running, at least why I took this video, right? But between Stack Overflow, the health dashboard, the API documentation, there should be a lot of references or resources out there for you. All right, so now really, I would say that the core of my talk here is showing you a demo of what you can actually do. And this demo I'm going to show, I'll give you some links at the end. There's actually a reference code. You can take this, you can run it, you can fork it. You know, really, I want to show you what can be done and what did I do to kind of glue some of these workflows together. So again, all starts with Inventor. So I've got this processing equipment skit in Inventor. Right? It has a whole bunch of iLogic rules. Well, not as many as the drainage system, but it has some. Right? It's got a form, so you can bring this form up. There's a bunch of rules and parameters you can set in the form. So I'm going to go ahead and change the skid. I'm going to make that just a little bit wider. I'm going to go ahead and make the vessel a little bit smaller. And I'm going to go ahead and add a cabinet here. Right, so adding that cabinet's going to create some geometry and place it in the right place. Right, all driven by iLogic. Right, so those are just some changes I can make. Most of you have probably done this today. Go ahead and change your parameters, run your rules, drive those all from an iLogic form. So what I did here is took that same assembly, but you can actually take any assembly into this, and then I'll walk you through that here in a minute. And we're going to extract the parameters, the user parameters, from that model. We're going to then be able to update changes based on the parameters, just like we did in Inventor. We're going to be able to extract some BOM data, create a drawing, and then download the outputs. Right? So this is a CSharp web app that I built. There's 4 app bundles that go with it. I'm just hosting it locally right now. You can download this and host it locally. You can host it in the cloud. One of the things I want to do, back to the safe harbor, don't know when this is happening, I would love to have this be just a one-click deploy and run and try it out. Right? Not quite there yet, so there is still some building and either running it locally or deploying that has to happen. But the code's all there. Okay, so you'll notice here you have an input file dropdown, a document path, and a project path. So as long as you upload an assembly that's kind of set up the same way as this. It should really work on any. So I'm going to go ahead and click my processing equipment zip file, which is a zip of the assembly, specify my top level assembly file, and specify the project. It goes off and runs a work item. I get back a unique ID, and 38 seconds or so later, I come back with a result and all my user parameters. So I sucked all those out of the file. Again, ran this on Forge, got the results back. I've got a viewable. Cool. And you can see I've got all those user parameters. Not nearly as nice as the dialog, but this is really just reference to show you what you can do. All right, so what I'm going to do now is take those parameters, and I'm going to go ahead and change a few of these parameters. So I'm going to go ahead, and you can see here we got the same values that we had in the iLogic form. I'm going to make that skid wider. I'm going to make a smaller vessel, and I'm going to add the cabinet. Now, you'll notice it doesn't update right away. That would be nice, but we're running jobs here right now. So I'm going to go ahead and update that. Again, you get a new work item ID. And for this model to run those rules and load it, a little over 2 minutes at the moment. So, you know, it's not snappy, but it definitely is going to do the job. It comes back. And again, without needing the Inventor, you will get wider skid plate, cabinet added, and a smaller vessel. So we actually processed that all in the cloud, got that back, and then you'll see here. So the other thing I provided this log panel, and this will give you some of the results and some of the information. You're able to log information as you run your add-in. It will show up here in the log as well. All right, so the next thing I want to do is extract some bill of materials information. So again, I'm going to go run a work item, extract things like the quantity, the description, the material. I just picked a few of the things out of the bill of materials, but this is something that you could do if you want to integrate with another system. Is really a cool part. Maybe you just care about part of the BOM, or maybe you want to connect part of that BOM to an ERP. Because you now have an API to do that, there's ways to do it. So you see here, I just dumped out the whole BOM I got back, and you can see, if you look at cabinet, we've actually added the cabinet that I added via the form. Right? So this at least shows you a little bit of what you can do with the Power Design automation. But a lot of people, at the end of the day, end up generating drawings. Right? So a lot of things need to hit the shop floor or need to come back for a quote as a drawing. So we're going to go ahead and run another job. I have a template drawing that we derived this from. I then have my iLogic rules that generate the drawing. You can see that in the model if you want to download that later. It's a little under a minute, I think, for this one. Comes back, and we have a drawing based on those configuration changes I made. If I'd had more time, I could have generated a parts list or done some annotations. Right now, I just create a view, and then these notes come from the template. So I just wanted to show you how to bring a template file in, how to create some amount of drawing content, and then get that back and display it in the Forge viewer. Right? So in both of these examples, maybe what wasn't so apparent is I'm actually giving you that Forge viewable back and showing you a way to host that locally without going through our model derivative service. And a lot of our customers, as we talk about configuration, it's been a pretty important workflow step for them. So the last thing I want to show here is download. So I show an example of two things here. I'm going to show how to get the actual BOM data back. So I format it in a JSON. You can take my app bundle and create a CSV, or maybe there's some other integration you have that you want to connect your BOM with. So I'll just show you I got the BOM data locally. You can see here in the JSON file, I've got all the BOM content back, right? So that's kind of cool. The other thing I want to show is getting the Inventor assembly. So this could be the drawing, but I just wanted to show you that we can get the updated assembly back as well. So again, with design automation, we work with zip files right now. So you zip up your assembly, you hand it to us. If it's an assembly you want back out, you'll get that zip file. So we're going to go ahead and extract that zip file back out. And you'll see here, even as we extract, we've got things like the libraries of content that we have along with the model. So we have some content center parts in here, so I wanted to show you it would work with it. And we get it back in a way that, again, you can bring completely back into Inventor. and you'll actually see in Inventor the changes we just made in the cloud. So you've actually seen a round trip now, going from the initial base model of Inventor, run all the way through, some content generated, and then this model brought back into Inventor. Again, I hope the skid plate's wider and the cabin's been added, and the vessel's smaller. Yep, there we go. And bring up your parameters. Let's just verify a few other things. You can actually see that the parameters were updated. Yeah?
There was the same file tables that you were proposing.
Yes.
There was some tables that you were
So I'll actually walk through that next. Great transition into my next slide. Yeah, if this doesn't answer your question, let me know. So the question was, where was the zip file? So let's walk through the extract parameters workflow here in a little more detail and see if that both helps answer your question and maybe shed a little more light on what's actually going on behind the scenes here. So right now, I'm using Forge Data Management to store the initial Inventor assembly, which has the initial assembly, the iLogic rules, the drawing template, all the content. It's all in that zip file. There's some JSON, which specifies the top-level assembly, the project file to use. And then you've already uploaded your app bundle. So that's the app bundle code also. You've uploaded that to Design Automation, so we hold on to that. Right? As the job runs, you've specified in your work item where the actual Inventor assembly is. You give us a assigned URL to that. Typically, we'll download that onto the worker. We'll get the parameters JSON. We download your code onto the worker. We then load your add-in into Inventor and bring your input files in. That generates the output file. So for the extract parameters work, we get a JSON file back with all of the parameters as well as a Forge viewable. It comes out the other side. We then put that back into Forge Data Management. Again, up here and down here, this could be any cloud provider. Right? So did that help answer your question? As far as where the zip comes from? Yeah. No, you just upload it once, you tell us where it is. Yeah, your jobs will actually, yeah, so you don't have to worry about deleting this stuff. You just tell us where it is and we pull it over onto the worker. And then you can bring some things back to your web service. So for this example, I pulled that parameter JSON file and the Forge viewable back onto my web service. And then once we're done, I clean up the worker. It's gone, but your data is still in the cloud. So the next work item can pick up that zip file and use it again. We just don't leave it hanging around on the worker. All right, so I want to walk through one more just to make sure it's clear. So if you look at the update model workflow, the input files are, again, the Inventor assembly, the top-level assembly and project file, the updated parameters in JSON format, and your app bundle. Right, we bring those things in, we run them through our engine, we give you the output. So in this case, the outputs were an updated Inventor assembly zip file and a Forge viewable. Right, we use this updated zip then for all of our other downstream workflows. So generating the drawing, extracting the BOM, doing the download, all come from this new zip file here. We store that in the cloud. And for this, you just actually care about the Forge viewable for now. Because you're just updating the parameters and updating the view. You just care about the Forge viewable. Right? So that's the basic steps. And then at the end, again, we clean off the worker. All right, so show me the code. So the code is here. It is, so how many of you, I guess we've got a couple developers, are C-Sharp developers? Or your teams work with C-Sharp? Okay. So these will probably, help you a bit. Even if not, some of this it should be pretty straightforward to read through. So the core of this is there's a .NET web service, all written in C-Sharp, that is the web service, the client code. I'll walk you through that here in a minute. And then these 4 app bundles, right? So I have an app bundle that extracts the parameters. I have an app bundle that updates the model. I have an app bundle that extracts the BOM from the model. And I have an app bundle that generates a prime. Right? And I think over time, I want to kind of add to this demo, and we'll just add app bundles, but really wanted to provide these as basic building blocks or starting points. If you want to automate these kinds of workflows, you can take this code and use it as a base, or at least use it as a reference to see what can be done on Forge. So if we look at, I hope you guys can read that back there. This is the web service, right? And there's three main parts, at least in this web service. I wanted to give you at least some exposure to know where the basic parts are here. So we have this design automation controller, and this is the web service. So these are the things that actually get called on your web service to connect to Forge. Right? We also have a top-level index.html file, which provided the layout, defined the tabs that I was showing. Not all that interesting, but the more interesting bit's going to be on the client-side JavaScript. So this is actually the thing that calls into the web service, that gets the update, that does a lot of the communication back and forth with the web service, that the web service then communicates to Forge. So this is on GitHub. I've got links on the previous slide, so feel free to go, take a look at the code, get it running. If you have questions, please let me know. And then I wanted to walk you through one of our app bundles. So this is the one that, I'm going to upload one that updates the parameters, right? So I'm going to go ahead and open this here in Visual Studio. Open the top-level assembly. And there's three main parts to these app bundles that I'm showing you here. The actual plugin code itself. There's a project to debug it locally. And then there's something to actually upload your app bundle and create an activity for you. So that's the interaction one. If we look at the actual sample automation CS, this is actually the add-in that's actually extracting the user parameters. So here you'll see how we actually get the parameters back for what the top-level assembly is in the project file. I'll show you an example of how to get those from the inputs. I'll show you how to set up your project, as well as load the top-level assembly. And then we actually walk through updating the user parameters based on the parameters that were sent in. Right, so this is CSharp code that interacts with the Inventor API. And again, I just want to make sure we call out the three main projects here, because they're super useful. The top one does let you run it with a local version of Inventor to test it out before you actually deploy it. Actually having something that creates an app bundle, updates a new version of it when you change the code and creates an activity is super handy. I use this all the time. I used it as I built this demo app out. Right, so we're going to go into a little bit of how. So I've shown you the what. I've given you some reference code for the what. It's up on GitHub. Please reach out to me if you have questions about that. But then, how can you get started? There are some resources today. So back at AU last year, I did a session on bringing your existing Inventor add-ins into design automation. This goes into some more of the detail on how you actually can refactor some of your add-in, as well as how you build a app bundle and an activity to define your add-in, and then how you drive that with a work item. So this is posted online on the AU website. You can go take a look at it. We have updated some of the tooling since then. I'll go into an update. I'm actually going to do it at AU this year. It's going to be an update of this class, but this is still a great place to start. Another good place is I gave a webinar back in May. If you want to go into more details on what these basic building blocks of design automation are, how they can apply to some workflows in your company, and this would be another good resource for you to go take a look at. And shameless plug for AU Las Vegas. I don't know if any of you are planning on going, but some of these will be recorded. And I want to put this up here primarily for the getting started with design automation for Inventor class that I'll be doing there. So I don't remember how long it takes for AU classes to typically get posted online. Do you know, Kevin? Well, I said keep an eye in December sometime. This class will be all about the how. So it will be all about the current tooling we have in place, some of the things I think are going to make it easier to get up and started, with getting your add-in converted. Really some of the nitty-gritties on best practices and debugging are going to be covered in that class. I'll be giving this class again there, but the other two things that will be sort of interesting, I'll be co-speaking with one of our product managers around just how to automate, what to automate, so taking some of the principles and how they might apply to your business. And then if any of you are planning on going to Las Vegas, or you have friends that are, I'll be doing a meetup there, where it won't be recorded, but it'll just be a place to actually have customers talk to each other about what they want to do, and then talk to the product team as well. All right, so a couple of practical places on really where to get started. This is the core of where you're going to want to go to get started to start your add-ins. So this is what I use for those core references that I showed you, but if you want to start from scratch, go get the Visual Studio template that we have up online right now. I think we have over 1,600 downloads when I made this screenshot. I think once we get to general availability, this number is going to go way up. This creates that debug local, the interaction to upload your app bundle, as well as all of the bootstrapping code to create the plugin, to create a GUI for you, register the column object, all the nasty stuff that you'd have to do and figure out, it just generates for you. So our team did this. I'm super, super happy with it. Customers who've used it have been really happy with it too. I wanted to show our Postman collection. So have any of you used Postman before? Got a couple out there. So if you haven't, and if you're just getting into doing web programming, this is an amazing tool. I probably couldn't have got that demo running without it. It really gives you visibility. What I'm showing here is just, I make an interactive API REST call to get activities, and it dumps out the list of my current activities. So it's a great debugging tool to actually see what's going on inside of Forge, kind of interactively, without needing a program to run it. And I've talked to a few of you about accelerators. So how many have been to a Forge accelerator? All right, a couple hands. So I went to the one in Boston. It was amazing. I was able actually to work with customers. It's amazing what you can do in 3 or 4 days. Come out with something working at the other side. You know, I worked with one of our resellers and came up with a really awesome configurator. It really was in 3 days worth of development effort. You have the Forge development team there. You have other customers you can work with. Great opportunity. So out on our forge.autodesk.com website, there's a link to this. You can go take a look. You do have to apply for them. So if you have a project you think would be helpful to go through one of these, you know, this would be a great time to connect with some of the Forge team. Come talk to me afterwards. There are other tutorials out there. So we have this Learn Forge framework. So more than just design automation, if you want to just learn more about Forge and how to get started, this is a great resource as well. So this is up on, make sure we got this right. Yeah. learnforge.autodesk.io. Again, that'll all be in the slides here. We have a bunch of things up on GitHub. So right now, my samples are all in my personal space. I'll be moving this over. Because we've been in beta, a lot of our stuff is in the developer Autodesk GitHub repo. We're working on moving that over. But I want to show you both these because you'll want to look in both of those places right now. You'll find our Postman collection in the developer side. You'll find we have a CSharp example. So you'll still find a bunch of resources there. I just want to let you know they're there. We're working on moving those over. And then to kind of wrap this up, I wanted to give you some references. You know, we have a bunch of community links here. So we have, you know, we have a Twitter and Facebook page. We have a YouTube channel. We have a Forge blog. So if you haven't looked at the Forge blog, there's content added all the time. There's been design automation content, there's been viewer content. A lot of the Forge experts contribute to this regularly, right? And then really, like I mentioned before, Stack Overflow is by far the best way. If you have a question, post it up on Stack Overflow. Somebody on the community may have an answer, but it also gets funneled into our Forge support system. So it's a great place to go to look initially. It's also a great place to go. Those questions will get down, even eventually to the development team, if the support team can't answer it directly. So definitely go take a look at that. And then really to get a hold of me or anyone on the design automation for Inventor team, we have this, make sure I get that right, yeah, Inventor on Forge at Autodesk.com. Both Kevin and I are on that. If you have a business question, if you have, want to have a follow-up, this would be a great way. Feel free to reach out to us. I think with that, that's what I had to show here. I definitely we've got about 10 minutes here for some questions and answers. So, anyone out there have specific questions on either what I covered, what you're trying to do? What happens if you upload an assembly with an unresolved file, right? Well, it won't get stuck, but you probably aren't going to end up with the right assembly out the other side. So since we don't have dialogues, we'll go ahead and do, basically if you've done a skip, we'll load the file, but you're probably going to be unhappy. So, that's one way to, when you do the local debugging, we actually have an input file folder. The best way to do that is bring everything into that folder and make sure that your project isn't referencing something off that isn't in that code. Right, that's definitely, we've had people work through that, and that tends to work pretty well. Yep. So yeah, the question was what happens if your code contains some Windows code? Yeah, so the add-in stops because it can't load the window code. So a good example of that you'll actually see in my bringing your add-in class that I did last year in AU. You'll actually see in the log file, like, can't load this DLL, or there'll be an entry in that log file that you get back. It's another good way of testing it locally, but again, you have full access to the API and other DLLs when you're running it locally or testing it locally, so sometimes it doesn't get caught until you actually deploy. The log file will show all of those though. Yeah, that's a good question. I don't know if Emily's here or anyone knows where. There will be access to these. If not, let me know or contact Inventor around Forge. I can get you copies of these. But yeah, I think all these presentations will be available online somewhere. So I think that would be a good question for Kevin, because you want to bring those Unity plugins typically into Max, right? Not Inventor directly. Is that right? Or do you have workflows where you have Unity plugins in Inventor? Okay, come chat with me about that afterwards, because I'd be curious to see. You can bring other plugins in, like I said, custom plugins. If it's just code that's going to run, it might work. If it needs to connect with another service or launches any kind of UI, usually that's where things start breaking down. Kevin? Yep. Yeah, so again, where we're at right now is those files have to get downloaded onto the machine. We've actually got to load that whole thing in session, then make the changes, then give you the results. That's what took those 2 minutes. We're looking into things in the future around what we can do for effectively what I'm calling data caching per customer. So there are ways that we can provide better, quicker access to that data. Again, things we're looking at. So for customers who don't care about interactivity, often that's okay. If you do, again, come talk to me, because I really want to understand your workflow. I do understand that, downloading the data every time, having to upload the results back, especially for doing like assembly, parallel processing, and workflows like that, it can become a challenge. Yeah. Right. Any other questions? All the way to the back. question was around how you manage access from the end customer getting access to the initial design. Is that right? Because typically they're running through a configuration workflow. Maybe you just want like a neutral file output or something like that. You don't actually want to give them access to the source code, right? Yeah. So yes, and typically that's done when you as, let's call you an admin who control the design. Right? You're the one who has the web service. So you don't actually have to give them access to the input file. You have to give us as a worker access to it. But you can give them access to just the output or part of the output. So you can give them access to maybe like a PDF of the drawing that got generated. Right? You would not have to give them access to the input file. Now, Forge has to have access to that input file to process the data, but your end customer doesn't have to. So if this demo app was running and I had an end customer hitting this demo app, I could actually even have those sets of files listed. So let's say you had a processing skid and maybe you had another kind of skid and multiple types of inputs. Those could just be listed as input designs with no access for the end customer for that source data. Yes. Yeah. The data stored in the cloud somewhere. You control that. Yep. I think we have time for one or two more. Yes, we do support, the question was native code support. So there's a couple ways to do that. We do support native C++ add-ins today with unmanaged C++. It's not documented nearly as nicely as the C-Sharp. We have a lot of examples in C-Sharp. I have some examples, with Node.js web servers. Right now, we haven't had a lot of customers ask for that. You can also use things like pinvoke to call through to native code. Now, if that's going to be non-performant for you, you certainly could write an unmanaged C++ add-in. Right. There are no more questions. I'm here all day. I think I'm the only one wearing an eye on my shirt. So please come talk to me. I'd love to find out more about what you want to automate and some of the challenges you have. So with that, happy automation.